tangent functions, we always have to use the parent function as a reference. So the parent function of tangent is f of x equals tan of x. The transformation equation for tangent functions is f of x equals a times tangent k times x minus c plus d, where a is the amplitude. But tangent functions go on and on forever, and down, down, down forever. So the amplitude doesn't really exist here. K is the periodic shift, c is the phase shift, and d is the vertical shift.
Looking back at our parent function, we don't see a, k, c, or d in this, because in this instance, the amplitude, or in this case the fake amplitude, is 1. The periodic shift is 1. The phase shift is 0. And the vertical shift is 0. The parent function has no transformations, which makes it the parent function.
Let's take a look at an example equation of a tangent equation. And let's define our variables. So the amplitude is 6. The period, which we learned from other videos, is pi over 3. The phase shift is pi over 6, but because the original transformation equation is x minus c, the phase shift would be negative pi over 6, and then the vertical shift, which moves the graph up or down, is down 1 because of the minus 1 actually, sorry. Let's first practice graphing the parent function.
Unlike sine and cosine, the tangent has a period of pi, and it also has asymptotes, which are represented by the dashed lines. In tangent, half of the period is to the right, and half of the period is to the left. So since the period is pi, the asymptotes would be at pi over 2 and negative pi over 2. And the amplitude points, so those a values, will be met at a fourth of the period. So pi over 4, in this instance, would go up to 1, and then negative pi over 4 would go down to negative a. So, yeah.
Also notice how the parent function of tangent goes through the origin. So the 3 points we want to highlight is pi over 4 to 1, pi over 4, comma 1, 0, 0, and negative pi over 4, negative 1. To transform the parent function of f of x equals tangent of x to 6 tangent times the quantity of 3 times the quantity of x minus pi over 6 minus 1, we're first going to do a table of the original points. The original points of a tangent graph that we're going to graph today are negative pi over 4, comma 1, negative 1, 0, 0, and pi over 4, comma 1. Our amplitude is 6, and because looking all the way up here, our amplitude is not inside any parentheses, so it's only going to affect our y values. So what we did here was we multiplied all the y's by 6, and you can see we went from the original points of the y values being negative 1, 0, and 1. They're now negative 6, 0, and 6. Next, we are going to apply the vertical shift. So looking back at our equation, well, no, we're not going to do that right now. I wrote down the next transformation, which is down 1. So it's going to take these points right here and subtract 1 from all of them.
And now you can see the new points where it was once negative 6, 0, and 6. It is now, well, the y values are now negative 7, negative 1, and 5.
Lastly is the phase shift, and you see that the phase shift is inside the parentheses. So it's going to affect what? Your x values. It's going to move all of them according to this sign here. But in transformations, things in the parentheses are always the opposite. So what that means is that because even though this is a negative pi over 6, we're actually going to move every x value to the right.
Okay, so we have added pi over 6 to each of the x values, and we got negative pi over 12, pi over 6, and 5 pi over 12. And our y values stayed the same. So now all we got to do now is just apply this to our graph.
And here's the jank-looking version of the completed graph, where we graph the points pi over 12, negative 7, pi over 6, negative 1, and 5 pi over 12, 1.